Today's lesson is a continuation of section 5.5, write equations of parallel and perpendicular lines. I'm going to go through an example of a problem we might see here in a second, or just something that I would expect us to be able to do on a typical maybe MCA problem or test problem. But I'm going to backtrack for a second and go through an example of one, what we were going yesterday, and two, it's actually a problem from the assignment I gave for the previous lesson, number 18 on page 322. That problem says write an equation of a line that passes through the given point and is perpendicular to the given line. And we started talking about this in the last lesson. So again, if this is something you're still maybe having trouble with, watch the previous lesson, because that one more talks about how we begin writing equations of lines that are parallel and perpendicular. But I'm going to go through one here as an example and just to emphasize the steps and what we do, and also show us one other way we can do a problem like this. It wants us to make a line that's perpendicular to the one they give us. In this case, that's y equals x plus 5. So again, what I talked about yesterday is usually we find m and b for these kind of problems if we're going to make an equation. Well, the slope of this line, and there's no number in front of x, but really if there's no number, it's like the slope is 1. But now remember, if I'm going to make a line that's perpendicular, like we talked about in the last lesson, what I'm going to do is I'm going to take the negative reciprocal of the slope of this line. So the negative reciprocal of the slope of that line, in this case the slope is 1. Well, the negative of that would be negative 1. And 1 in this case is kind of a funny number. It ends up being the reciprocal of 1 is still just 1. So in this case, the slope of the line that I'm going to use is negative 1. Just as a reminder though, again, because this is kind of a funny case, but let's say I have a slope of a line that's 2 over 5. Just kind of a sidetrack example here, but just making sure we remember this concept. If I have a slope of a line, let's say it's 2/5, if I want to make the slope of the line that's perpendicular to that, I'm going to take the reciprocal of 2/5, which would be 5 over 2, and I also am going to make it negative. That would give me the line that's perpendicular to it. That's the relationship between perpendicular lines. One slope is the negative reciprocal of the other. Okay, so just something to keep in mind. In this particular problem number 18 though, if I have a slope of 1 for the original line, the negative reciprocal actually is negative 1. So I take that, and now I'm going to find out my y-intercept for this line by using the point they gave me and the slope, the new slope that I found. So I really don't need the original line anymore, okay, or its slope. I just needed it to tell me what slope I'm going to use for this problem. So my slope that I'm using is negative 1, and I'm going to use this point, which again is an x and a y coordinate. Well, like we've been doing for a while now, y equals mx plus b. What that means is I'm going to put negative 1 in for m, because I want the slope of the line that's perpendicular to it, so I'm going to use negative 1 for m. I'm going to put 3 in for x, negative 3 in for y, so negative 3 equals negative 1 times 3 plus b. Negative 1 times times 3 gives me negative 3. And then if I'm going to add 3 to both sides, in this case, it actually cancels out both 3's, cancels out in both cases, so I just get b equals 0. So for this particular problem, the y-intercept ends up being 0. It's a proportional relationship. If I'm going to make the equation, I could say y equals negative 1x, or just y equals negative x also would be the same thing. So either of these two answers would work. But there's kind of an example, again, of what we were starting to learn from the last lesson, how to make a line that's perpendicular to the given one. Now here's what I've been also saying more of in class, and something that I'm becoming more of a fan of as well. Some students really like this system. They like plugging the numbers in for variables. Okay, this makes a lot of sense, just kind of working with an equation, substituting things in, and finding out the answer, finding out my y-intercept, and making my equation. If this is something that you're having a little bit of trouble with though still, or if you're just more of a visual learner and it helps for you to see the problem better, or see really what's going on when we're talking about finding the perpendicular line, you may want to do some of these problems graphically. And I am totally fine with that as long as you're getting the right answers and you're understanding better what's going on. If this gives you a better understanding of what we're doing, then I would say use a graph to do these problems instead. I'm going to show you how you can do that right now. And again, if you need graph paper, I always have some in my room. Or if you have your own at home, great. But I would encourage them. I'm starting to, myself, I'm becoming more a fan of doing them this way as opposed to the algebra. I think some students, if they still have trouble with the algebra, it's because they plug numbers in, but they don't know why they're putting them in where they are, what these numbers really are meaning in terms of the graph and what's happening. So I think when you make the graph, it's a better visual of what's really going on in the problem. So I'm going to show us, well, how can you do a problem with the graph instead? And then I'm saying this could be a substitute for all the stuff that's in the red box. You wouldn't have to do all this. You could instead just do this on the graph. And if this makes more sense to you, I'd say do the problems this way, and you can show all your work just by doing that. So first, okay, again, go back to my problem. What they want me to do is make a line that's perpendicular to this one right here. Make a line that's perpendicular to that one, but it goes through this point. Okay. So here, well, first I'm going to graph the line they give me on there. Okay, y equals x plus 5. The slope of that line would be 1. The y-intercept would be 5. So I go up 5 and start right here on the y-axis. And I go up 1 over 1. Up 1 over 1. There's my slope. So here's the line they're talking about, first of all. They want me to make a line that's perpendicular to that, but it also has to go through this point. So I'm going to do this point right here in green. Okay. Here's the point, 3, negative 3, over 3, down 3. They want me to make a line that goes through this point right here, but makes a right angle when it crosses through the black line. You can almost even imagine what this would look like. Okay, if I just kind of just rough hand draw one. Okay, I'll take it away in a second, but if I just kind of rough hand draw it, there's what it would look like. It's got to go through that point, but it's going to intersect at a right angle here. Okay. Well, I'm going to kind of just backtrack and show you exactly how you would do it to make sure you have the right answer. Even doing it this way, it doesn't mean you still miss out on understanding the concept we're working on. Because what you got to think is, okay, well, the slope of this line, the black line, the original, the slope of this line is 1. So now, if I'm going to make a line that's perpendicular to it, you still have to know what that slope is. And like we said earlier, well, then the line that's perpendicular to that one would have a slope of, well, -1. It'd be the reciprocal of 1, which is in this case 1, and you make it negative. Well, I know what a slope of -1 looks like. That's down 1 over 1. Down 1 over 1. And I just start from that point that I know the line goes through, so down 1 over 1. And I could backtrack. I could go the opposite direction as well. Up 1, left 1. And I could make a bunch of points here just to make sure my line is nice and straight. But there would be the line that I'm trying to find. And by making all those points up 1, left 1, up 1, left 1, I can see right here, there's the y-intercept. In this case, it's just 0. So I found out just by making a graph, my b is 0. So right now I can make my equation, y equals, again, -1x plus 0, or I don't even need that. Or again, I can just say y equals -x. And there's my answer. What do you know? Yeah, it's the same answer we got over here. So what I'm telling you is either way you do the problems, oops, I hit the extend page there by accident, but either way you do this problem is fine with me as long as you're getting an understanding of what we're doing and you're getting the right answers. You could do option number 1 just like we've been doing for a while. Okay, option number 1, which is just doing it the algebraic way, or option number 2, which is using a graph. Either way gets you to the right answer, and I just want you to do it whatever way gives you a better understanding of the problem. So I'm fine with either one. I'll try to do a little bit of both on the board as I'm going through problems in class, but you pick out whatever method. If it's still number 1 and you're doing good with method number 1, then you can stick with that. If you're having trouble or you just want to try something different, and maybe this gives you the visual way, gives you a better understanding, then try method number 2. But either way is fine with me. Then I'm just going to show us a typical problem we definitely could see on an MCA, on an MCA test, or on a test I might give here in class, or even a homework problem. But I've seen problems just like this many times as students are going through this kind of section, working with these kind of problems. So this is a problem that something we also need to work on a little bit. So I'm going to go through this one right here. It says it gives you 4 different equations, or the problem will just in general give you a few different equations, and it'll say tell whether the equations are perpendicular to each other, or parallel, or neither. And so if I'm looking at all 3 of these equations, or also all 4 of these equations, this first one, the blue one, -2x plus 3y equals 15. The thing that'll tell me whether they're parallel or perpendicular, or neither of those two things, is I need to know the slope of each line. I need to know each one's m. Well, if I look at this equation, though, it's not in slope-intercept form. Just remember, slope-intercept form is a great thing, and we can pick out the slope from it immediately. But an equation has to be in slope-intercept form for me to do that. -2 is not the slope of this line. I need to have it so it's y equals everything. I need to have this equation solved for y. Remember, here's slope-intercept form. Y equals mx plus b. I got to get it looking like this first, where y is all by itself on the left side. So in this problem right here, again, pretty typical problem, something students will definitely see again and again. I got to get y by itself right here. So what am I going to do? Something we practiced. Well, the first thing I can do is I can add this 2x to both sides, because what I'm trying to do is eliminate things from the left side. If I add 2x, that gets rid of this. Now I'm getting closer to getting just the variable y by itself. If I add 2x to this side, now I have 2x plus 15 over here on the right side of the equation. And my last step is divide everything by 3. So I got y equals 2 over 3x plus 5. So I know that the blue line has a slope of 2/3. That's what I needed to find out. Okay, we'll keep that in mind. To the red line. Red line, same thing. It's not in slope-intercept form. So first I got to get everything away from the variable y. I'm going to subtract 3x from both sides. That'll get rid of it over here. Now I've got 2y equals -3x plus 4. Divide everything by 2 to get the coefficient of 2 away from y. Now y is just by itself on the left side. That's what I want. -3 divided by 2 just gives me -3 over 2x. And then my y-intercept is 2. So for my slope for m, for my red equation here, I got -2 or -3 over 2. Okay. Going down to the green equation. This one just takes one step to get y by itself. I just have to divide everything by 3. Gets rid of the 3's on this side, on the left side. So now I have y equals -2 over 3x minus 1. Slope of the green line is -2/3. And the black line here at the end, same thing. I gotta get y by itself, so I'm gonna add 4x to both sides. 6y equals 4x minus 18. Divide both sides by 6, and I just gotta divide every single term by 6 and it'll work. So y equals, well, 4 over 6 is really just 2 over 3, if I reduce that fraction, minus 3. So the slope of the black line is m equals 2/3. Okay. Again, problem that they definitely might see on a quiz or an MCA is something like this, where I've given a couple different equations, and now I'm not done with the problem. Okay, I found the slope of each line, which is what I need, but now I got to determine which ones are parallel, which ones are perpendicular. Well, let's look for parallel lines first. Okay, which lines are going to be parallel? What do parallel lines have? Parallel lines have the same slope. So if I'm looking at these, which ones have the exact same slope? It looks like here the black line and the blue line both have a slope of 2/3. Okay, so I could say the blue line is parallel. That's a little shorthand for it. Two lines like that. Blue line is parallel to the black line. So maybe one thing I could point out. Okay, I know that. Any other lines parallel? No, the red one's -3 over 2. That's not the same as any of them. The green line's -2 over 3. Nope. So no, none of the other lines are parallel. So that won't help me. Are any lines perpendicular? Again, what does it mean to be perpendicular lines? Well, that means that the slope is the opposite reciprocal of what I'm looking for. Okay, of the line that they're giving me. Okay. Well, the green line here, the opposite reciprocal of that, so would be perpendicular, be positive 3 over 2. Okay. Well, I don't have any of those that have a positive 3 over 2, so that one's kind of out. Green isn't in the case here. If I look at the red line, what's the opposite reciprocal of that? Well, that slope would be positive 2 over 3, which is what I got actually for both of these. Okay. So actually for the red line here, it's perpendicular to both the blue and the black line. So I can say the red line is perpendicular, again that's the symbol for it, to the blue line. And also the red line is perpendicular to the black line. Again, in this section, the two big things that we got to understand is how parallel lines relate to each other, how their slopes do. And again, that's kind of a review though. That's something we've known from chapter 4. Parallel lines have the exact same slope. That's why they're parallel to each other. Perpendicular lines, the relationship we need to know is that the slopes are opposite reciprocals of each other. And again, here's a typical problem where students might have to figure something like that out. So, like that concept, if we can understand that concept, we're doing pretty good in this section. So.